In the previous video, we looked at two special triangles. We looked at the triangle that was a 30 degree and a 60 degree, and we looked at the triangle which was 45 degrees. And we determined that the sine of the 30 degree angle here is just the opposite over the hypotenuse, and so the sine is a half, and that's the ratio of the length of the opposite side divided by the length of the hypotenuse. And we discovered that the cos was the length of this using Pythagoras we worked out was root 3 on 2. And therefore the cos of 30 degrees, which is the adjacent over the hypotenuse, is root 3 over 2 as we have here. We looked at the 45 degree triangle, which we determined that each of these sides was root 2 on 2. And so the sine is the opposite over hypotenuse is root 2 on 2. And so is the cos. And I've just redrawn this triangle here, the 30-60 triangle down this way, so that we can see here if this is the if this is the 60 degree angle here, the sine of 60 degrees is opposite, which is root 3 over 2 divided by 1. So the sine of 60 degrees is root 3 over 2, and the cos of 60 degrees will equal a half. So what I want to do now is I want to take each of these triangles and I want to put them on the unit circle. Now this unit circle here has a radius of 1, and so from the center to the outside here is a distance of 1. And I'm going to put each of these triangles onto this circle, and let's have a look at how we get these sine, cos and tan values. So I'm just going to move this down here and fit this triangle in to the unit circle. Now, as we've seen previous, the length of this side here is a half. That length is a half, and the length of this sine here is root 3 on 2. So I'm just going to mark this point here where this 30 degrees, this is 30 degrees, remember? So this point here is where this triangle fits into this unit circle, and that's the 30 degree angle from down here. And so this distance here is a half. So if I mark off this point here on the sine, this is going to be 1/2. And if I come down here and look at the cos length here, this point here, I'm going to mark that off, and this point here is root 3 over 2, because the length from the center out to here is root 3 on 2. So now I've moved the triangle away, and I'm left with this mark here on the circumference of the unit circle, which is where the 30 degree angle was. And if I read across to here, I can see that the sine value of this 30 degrees is a half, and the cos value down here is root 3 on 2. Now see what happens when I move this 45 degree triangle in. So let's pick up the 45 degree triangle and let's move it into the unit circle like so. And now looking again, we know that this angle in here is 45 degrees. I'm going to mark off this position here where the 45 degree angle bisects, or the hypotenuse of this triangle bisects or intersects with the unit circle here. And if I come across, I know that this length here is root 2 on 2, so I'm going to come across here to this angle here. That's root 2 over 2. And down here, obviously, the cos value is root 2 over 2. So for this 45 degree triangle, we know that the sine, which is the opposite, root 2 over 2, is read here, and the cos is also root 2 over 2. And now, lastly, I'm going to move in the 60 degree angle here. So I'm going to move this into my unit circle like so. And as with the others, I'm going to mark off, this is the position here where the 60 degrees hypotenuse intersects with the circumference of this circle. Down here I've got the cos value, which is a half, and over here I've got the sine value, which is root 3 over 2. And so now, getting rid of the triangles, this is how the unit circle is able to be used to calculate or to show us the values of these angles. So this is the part, remember the triangle fit in here, the 30-degree triangle. So if I come along here, the angle between, if I was to draw out to here, this would be 30 degrees. From this point on the circumference, if I measure across to here, I can read off that this is a half. And so this is the opposite, this is the sine axis, the sine of 30 degrees is a half. And if I was to come down to the cosine axis here, this is the 30-degree angle, and therefore the cos, or the cosine of 30 degrees, is this value here, which is root 3 on 2. And each of the angles and triangles that we've looked at so far works the same. Here's our 45-degree triangle, was fit in here, 45 degrees, the cos is root 2 on 2. Sorry, the sine is root 2 on 2. We read the sine off this vertical axis here, and the cos is root 2 on 2 as well. Same with our 60, and this is how we get our angles inside our unit circle. Now we can continue to use these same triangles to work the rest of the angles around our unit circle. First thing I'm going to do now is I'm going to flip this particular unit circle, this particular triangle. Remember, this is our 30-degree angle in here, so this length here is a half, and this length here is root 3 on 2. I'm going to fit this now into our unit circle like so. And you'll notice that if I was to read starting from here, I know that this is 30 degrees, I know that that's 30 degrees. If I was to go all the way around the unit circle to here, I know that this is 180 degrees, and so I need to come back this 30, so this point here is the 150 degree mark. So if I was to measure from this side here all the way around, it's 150 degrees. This sine value coming across back to my my vertical axis is a half. I know that this length is a half. And this length here is, we know that the length is root 3 on 2. So this point is minus root 3 on 2, assuming, of course, that we call this center here the origin. And I could continue to flip and move my other triangles into here, but symmetry and a little bit of geometry would tell us that this point here is going to be the 135 degree mark. It's you can either think of this as being 90 degrees plus another 45. If I come down to here, I know that the cos value is going to be negative root 2 over 2, and the sine value will hook up here and match up here with this root 2 on 2. And this point here is going to be the 120 degree mark, and the cos is going to be minus a half, and the sine will match up here with root 3 on 2. And this is how we can complete our entire unit circle, and it's all based upon those two special triangles. Remember what they are. They're the 30, 60, 90 triangle and the 45, 45, 90 triangle.